Hello. Okay. Okay. You guys can hear me, right? Hello. Cool. Perfect. Yeah. Sorry, there's some problem on my side. Okay. So let's get started. So in the last two lectures, we essentially talk about two different processes. One is something that we call conceptual modeling, right? So that is the step where you take one application that you want to build and try to describe it in a really precise way. And we talk about one way to deal with that, and that is via entity relationship model. You model your application by specify a whole bunch of entity sets, whole bunch of entities, and a whole bunch of relationships among them. And the second process that we talk about is called logical modeling. That is really to take as input your entity relationship model, the conceptual model, and try to translate that into some logical data model. And in this course, the logical data model that we care about is relational model. When you are doing this entity relationship modeling, the conceptual modeling part, we introduce one language to do that. And that is a graphical one called the entity relationship diagram. It essentially try to describe all the entity sites and relationships in your application. And you can put a whole bunch of other things like a weak entity, like kinetic constraints, so on and so forth. And when we are talking about relational model, right? So essentially our mentality model of data is pretty much look at a whole bunch of tables, right? So we talk about what is a schema. A database schema contains a set of relations, and each relation is each relation schema is a set of attributes or field or columns, depending on how you want to call it. Each relation has a name, right? So and also a primary key, and each field has a name or domain, right? So if you give me a schema look like this, it's kind of define a relation that looks like this. And in the last lecture, we talked about the process of doing this type of translation. Take as input a ER diagram and try to generate that, and try to generate a database in the relational model. And if you think about what we are actually trying to do, is that the conceptual model gives you a whole bunch of constraints. And then we are trying to implement that in a relational model. So in this lecture, we are going to talk a little bit deeper about constraints and think about a whole bunch of different things that we can try to enforce inside a database system. And then in the second half of the lecture, we are going to switch gears and to talk about one limitation that we are facing right now about SQL and how we can actually fix it by introducing something that we call recursion. Okay, so now let's talk about constraints in database. So what is constraints? So formally, by constraint, we mean essentially that's one way for us to define what is the set of valid database instances. And we have been looking at a whole bunch of ways of doing that. For example, there's key constraint, right? So every single relation should have a primary key, right? And if you give me a relation with this primary key, right? Essentially what you are trying to define is a set of instances that are valid. So here, this logical formula give you a precise description of what type of instances you are actually allowing, right? So I only allow the instance I if it satisfies this property. And we talk about type constraint. Right? Whenever you are defining a database schema, you are actually inherently defining the type constraint, right? Because for every single attribute of a relation, you are defining the data type. And that is a type of constraint. If you give me, say, okay, you have a relation where the first column has the data type integer, I cannot put a string in it, right? So that kind of constraint about what type of data I can put into my database system, and precisely speaking, it actually defines the set of valid database instances. So, and also, like whenever we are defining the schema, you are actually defining the shape, right? So if you have a relation with essentially two attributes, right? So I cannot put a tuple with three values in it, right? So whenever I'm defining a schema, I'm also defining kind of the shape of my data. So we talk about all these different ways to introduce constraints. And in this lecture, we are going to actually do more. And we are going to talk about other different type of constraints that you can actually specify in your database system to really constrain your data. And this is a set of constraints that we call integrity constraints. And they are actually the way that database makes sure all the changes that you have on your data, either by loading your data or updating your data, are consistent with your constraints, and to make sure they do not cause troubles later on in your applications, right? So, and also it is the way that database try to control the content of the data and its consistency as part of the schema, right? So whenever you are defining the database schema, relational schema, that is where you put all those integrity constraints that we are going to talk about today. Okay, so what are the examples of constraints that we hope to integrate into a database, right? So of course, there's our old friend key constraint, right? But there's also cardinality constraints that we talked about last week, right? So there's attribute domain, right? So, and then there's maybe subset relationship for generalization, right? For example, if you have a professor ID, if you have a person ID, you have two relations, right? One is professor, another is person. I want to make sure every single professor ID should also appears in the person relation, right? So all those subset relationships is going to be very useful. And there's those referential integrity constraint, right? So for example, I have a course, right? So, and it's taught by a professor, and I want to make sure whatever professor ID I put there need to be a real professor, right? So all those type of referential integrity constraint is something that we are really interested in. And in this lecture, we are going to try to talk about all of this. And if you think about database system, essentially there are actually two ways for you to specify constraints. One way is you enforce that by schema, which is the thing we are going to talk about today. And the second one is you can define something called a user-defined trigger that we are going to talk about in the next lecture. Okay, so now let's start from an easy one. So whenever you have a piece of data and you want to say, okay, so in this relation, I really do not want the value to be null. I want to make sure whatever data you give me, I only want to deal with data without null in it, right? So how can you do that? So you can do that by introduce the not null constraint, and you can write this in the schema. So here you are defining a table student with three attributes: SID, student name, and GPA, right? Whenever you are defining GPA, you can follow it by not null, right? If you do this, you are essentially define the constraint that whatever data you put in the database, I really do not want null value in the GPA column. If you give me a piece of data with null value in GPA column, I'm going to throw an error. Okay, so now let's look at some example. So assuming we have a database and we run this query to create a relation student, and we run this query, we insert a tuple where the student ID equals to 1, student name equals to B, and student GPA equal to 3.2, right? So will the database be happy with this, right? So it's actually okay, right? Because what's going to happen is whenever you're inserting this, database is going to check whether the value 3.2 is null or not. If that value is null, the database is going to throw an error because you have the not null constraint on the GPA column. Otherwise, the database is going to be happy and just run this query for you, okay? So essentially, after you run this query, you will end up with a relation with one tuple, okay? So the insertion will actually succeed. And then what if we continue to do this, right? So what if we run a second query to insert another tuple where the student ID is null, student name is D, GPA is 3.4, right? So in this case, it's also fun, right? So the not null constraint is only for that attribute, the GPA attribute. And you can put null value in other columns, it doesn't really matter, right? So the first null value doesn't really matter, right? The only thing matters for this constraint is whether this 3.4 value, right, corresponding to GPA is null or not, okay? And then of course, if you do another one, right, have 3F null, the database is going to throw an error because it violates your not null constraint, which is very natural, right? So And then you can actually, whenever you update your data, you don't need to just insert data to trigger the integrity constraint check-in, right? Whenever you update your data, the database is going to essentially check this constraint. So for example, we already run these 3 queries, 2 succeeded and 1 failed. And I will say, okay, so I'm going to update the student table. I will set GPA equals to null, where I set D equals to 1. Okay, so far, right, when you run this query, my database already have essentially 2 tuples in it. I have my first tuple, I have my second tuple, and then I run this update query. So what's going to happen is you want to update the GPA value of this tuple, right? I said equals 1 from 3.2 to null, right? So if you run this, after you run this, database is going to check the integrity constraint, right? So it's going to throw an error because then you will have 1 tuple in the database where GPA equals to null, right? So, and that's violated your constraint. So database will not be happy about that. So, but what about this query? So assuming we have these 2 tuples, this first 2 tuple already in my database, and then I run a query to say, okay, I want to update the student table. I want to set GPA to null, where I set D equals to 10, not 1. So the difference is that in my database, I actually do not have a tuple whose SID equals to 10, right? When I run this, right? So in this database table, I will make no changes to my data, right? Because I don't really have any tuples satisfy this where condition, right? So in this case, the database is going to be okay, right? Because what's going to happen is database is going to try to run this query and check the actual change, okay? So that's kind of important. So there could be some database instance for which running this query going to violate this constraint, but that is not what database cares about. What database cares about is you have your data, you run this query, you make some changes, and database is going to check that change, okay? So another type of constraint is primary key, right? So, and this is one that we have been looking at for a while, right? So a certain attribute is primary key, means that it need to be unique. You cannot have duplicates. And second, it cannot be null, okay? If you want to specify that, you can do it in this way, right? Again, the student table, if you want to say student ID is the primary key, you just write primary key following that attribute, right? And whenever you're doing this, essentially you are introducing a constraint saying that this, whatever you put in this column, SID, it need to be unique and cannot be null, okay? So let's look at some examples. So if you want to insert a tuple, right? So SID equals 1, student name is B, GPA is 3.2, database is fine with that, right? Because so far my database, my table is empty, right? So you want to introduce a tuple whose SID is 1 is unique because I don't have any other tuple with SID equals 1 in my table. So it's fine. It's not null. 1 is not null, right? So database is okay. It's going to insert a tuple for you. If you do this, insert another tuple where S equals null, right? Of course, database will not be happy about that because you are inserting a null value to the primary key, which by definition violates the constraint. Okay, and you can keep doing this. Right? If you insert another tuple where I said is 3, name is F, GP is null, this is going to be okay. Why? You have 3. The database is going to check whether you have another tuple whose SD is 3 in the relation. That doesn't seem to be the case. So it's unique. It's 3 is not null, so it's fine. And then if you insert another tuple like this, database is not going to be okay. Why? Because you have SID equals 1, and you already have another tuple whose SID is 1, so it's not unique anymore, right? Database is going to throw an error for you, right? So this one is getting more interesting. Assuming I already run these 4 queries, 4 inserts. So essentially I have 2 tuples in my database. I have one whose SID is 1. I have another one whose SID is 3. And then I say, okay, update this table for me. I want to set ID equals to 1, where GPA is null. Okay, so in this case, what you are trying to do is you want to update this tuple and set ID equals to 1, right? If you do it, you are going to violate the primary key constraint, because then you are going to have a new tuple whose SID is 1. That's not unique anymore, right? So database will actually throw an error for you. So it got a little bit more interesting. So let's think about this case. Assuming I already have a database with 2 tuples, and the first tuple has SID equals to 1. The second tuple has SID equals 3. Just like these 2 tuples. And then I run a query to say, okay, update this table, set SID equals to SID minus 2. I want to make the 1 into minus 1. I want to make the 3 into 1. If you run this, will the database throw an error? So this is interesting because it might not be deterministic. You could have a database instance for which running this will give you error, and you could have a database instance running this will not give you error. Okay, so let's just look at this. This is actually one example here. So let's say we have 2 relations, A and B, and they all have essentially one attribute, A as primary key, this B as primary key. And I insert these 2 examples in different order. Okay, for A, I insert 1 first, I insert 3, and for B, I insert 3 and I insert 1. Okay, so and then I run these 2 query. I update B. I will set essentially I will increase the B value by 2. Essentially, I want to turn this one into 5. I want to turn this one into 3. And then I run update query on A. I want to turn this one into 3, turn this one into 5. If you run this, this is interesting. Every single time I want to run this fail. Interesting. Yeah, something is not working. Okay, so then let's look at one example. Okay, so okay, let's look at this. So assuming I have relation A, where I insert tuple 1 first, I insert tuple 3. I have another relation B, I insert 3 first, I insert 1. Okay, so this is essentially the 2 relation. And if I say update A, set A equals to A plus 2. So in this case, what the database is going to physically try to do is it's going to update the first tuple first, set that to 3, and check the integrity constraint. In this case, it will actually throw an error. Okay, and if you do this, update B, set B equals B plus 2. In this case, physically, what database is going to trying to do is it's going to update this tuple first, and then it's going to become 5. And then you set this one to 3, this one's going to be okay. Okay, so this is why you could have a relation with exactly the same content, because we talk about relation, it is a set semantic. These 2 relations, A and B, are the same relation, right? So whether you insert 1 first, whether you insert 3 first, or whether you insert 3 or 1 first, it doesn't really matter. So these 2 are the same relation logically. But if you run the same query, for some of it, it's going to violate the key constraint, because you actually do not have the control on which order the database is going to apply these updates. But the underlying semantic is that whenever the database makes some update on some tuple, it's going to check the constraint. Okay, essentially for different order of doing the updates, which you do not have a control on, for some of the schedule database is going to have error, some of the schedule database will not have error. Okay, so that is why in this case, if you run a query like this, it will actually not be deterministic because you as a user have no idea about the update order. Okay, so in our example, right? So it happened to be the case, the database respect the order that you insert the tuple. For example, if I insert 1 first, database is going to put 1 first. If you insert 3 first, database is going to then then put 3, right? So, but that's not always the case. Okay, you as a user have no control on the data order. So essentially, you as a user have actually no control on whether this query, in this specific case, will throw an error or not. Okay, so that's a tricky part. But something that we to be on the same page of is that whenever you are updating multiple tuples, the underlying semantic by default is every single time you change a tuple, the database will check the constraint. If you are changing 10 different tuples, the database is going to check essentially the integrity constraint 10 times. Okay, so that's actually something that we learn by actually running this query. Okay, so there are more about key constraints. So you could define primary key over multiple attributes. It doesn't need to be on a single attribute, but you can only define one primary key per relation. Okay. So for example, I could define the combination of student ID and student name as a primary key of the student relation. This is fun, right? So the only tricky part is the database is going to check whether the combination of this pair is unique. And when we say it's not null, we mean that all the attributes in the primary key, in this case, both student ID and student name, cannot be null. Okay, so let's look at some example. So
actually,
I define primary key.
Can I interrupt you?
Oh, sure.
Sorry. There were two questions regarding so the first question, I think it's better if I just ask the question. So constraints are checked whenever we try to commit. And the second question, which goes hand in hand, what will the database do if updates of some tuples succeed? In the middle of the update, it throws such an error.
Okay, so I understand the second question. So can you repeat the first question? I'm not sure I understand that.
Yeah, so I think that was regarding I'm actually not sure exactly what it was for.
May I basically try to basically answer? Okay, basically I want to know because you said that constraints are always checked when the database changes the data. So my question was, since the database works in a transactional way, are these constraints checked every time when we finish a transaction, or are they always checked?
That's something you can actually set. I mean, so we haven't introduced transaction yet, right? But when we talk about it, you can actually check whether you check that during the transaction or whether you check that altogether after the transaction, right? So and that's something you can tell the database whichever way you want.
I see. Thanks.
Yeah. So I think for the second question, yeah, sorry, I can't forget the second question. Sorry. So what is the second?
It's all good. It was what will the database do if updates of some tuples succeed and in the middle of the update it throws such an error? So some pass, some not.
Oh yeah, so like in that case, database is going to roll back to the original state, right? So and essentially the goal of database to make sure your data is always consistent, right? So when we talk about transaction, you like you will see that kind of really precisely, right? So but here, whenever some update fail, it's going to roll back. It's going to roll back to a state as if the failed query hadn't been executed at all. Okay, so for example, I have two tuples. I want to update two tuples. My first update succeeded, and then my second update failed. Then database is going to roll back the first update. Okay, makes sense? Cool. Okay.
I also have a question.
Oh yeah, sure.
Sorry. You said in response to Alexander's question that you can set it to check if a constraint has been violated at the end of like an entire transaction, right?
Yes.
Would that imply that if you set it that way, that the example that you showed before, for example, where you do the ID -2, that you only check at the end that the primary keys are still consistent, then it would not fail regardless of.
Exactly. Yeah.
Okay.
So exactly, that is true. Yeah. So like if I said to say, okay, you only check the constraint after running the whole thing, right? So then this one will not fail, independently of the order you do in the update. But that's not but that's not the default behavior, at least in PostgreSQL. Yeah. Make sense? In PostgreSQL, if you just do this, like define primary key, if you do this, it's going to check every single tuple. Yeah.
Okay, sure. Makes sense.
Okay.
Thank you.
Cool. Yeah. Cool. Oh yeah. So if you have a question, just interrupt me, or you can just raise your hand. Otherwise, I cannot see like the stream of messages in the chat window. Okay. Cool. So key constraints, right? So in this case, right? So when I have the combination, right? So the first one is going to fail, right? Because I have SID here and I have SName here. Whenever I say a primary key cannot be null over multiple attributes, I mean, none of those attributes can be null, okay? So I can, yeah, so when you have one and null, I mean, it's going to violate your primary key constraint. So if you do this, 2 and 2 is going to be fine. When you have this, it's also going to be fun, right? Because it's going to check whether the combination is unique, right? So here, even though you have a student with the same ID equals 2, the combination 2 and 2, 2 and 3 are kind of unique. And therefore, if you do the third query, right, database is going to be happy. And of course, if you do this again, database is going to not be happy because 2 and 2, this combination is not unique. Right? It happened before. So this is what would happen if you have primary key. So essentially over kind of multiple attributes. So another constraint is unique constraint, right? So it's kind of very simple, right? So whenever, because I can only define one primary key per relation, right? What if there's another attribute I want to be unique, right? So in this case, you can just have the unique constraint to say, okay, so I know SID is a primary key, but I also want to make sure SName is unique for whatever reason. So in this case, if you only define this to be unique, right? So difference between this and the primary key is that this attribute can be null. It is okay. And null is actually unique. You can have essentially 2 null values in this column, and that's going to be okay. So let's look at this example, right? So I have SID as a primary key, and I have SName as unique. If you do this query, I have SID is null, SName is 1. The database, of course, not going to be okay because you are violating the primary key constraint, right? You are inserting a null value into primary key. If you do this, you insert SID equals 1, null equals to unique. What would happen? Database is okay because 1 is okay for primary key. And second, the SName column is unique constraint. I mean, it is okay if you put null value into that, okay? And you can, and null are different. 2 null values are different, right? So, and if you can, if you insert like this tuple, even though both of these 2 tuples have the null value on student name, and you have unique constraint on name, it is okay because you really don't really know how to compare 2 null values, right? So this is also okay. And if you insert this, it's going to be okay. But if you insert this again, right, so it's going to be not okay because if you check this thing, right, so you have one tuple with SName equals 1, you have another tuple with SName equals 1, right? It violates the unique constraint. Okay, so one thing you need to be really careful about is the difference between unique and primary key in terms of how they are dealing with the null value. Okay, Yeah. So different from primary key that you can only have one primary key per relation, you can have multiple unique constraints for one relation. When you have that, you can actually put unique at the end of the schema. Right. So here I'm essentially introducing two unique constraints. One is on the combination of SID and SNAME. Another is on the combination of SID and GPA. Right. So in this case, let's look at some example. Right. So if I insert a tuple where that whole thing is null, right? 3 attributes are null, right? So database is going to be okay, right? And I keep doing this, its database is always going to be okay, okay? So because unique columns can have multiple nulls, and that is okay, because null are kind of unique, right? You don't really know how to compare them. Okay. So now let's look at something a little bit more complex. So you can introduce essentially local checking of values of attributes. It's local in the sense that that's the type of constraints that you take as input a tuple, the whole tuple, and you can specify the condition, and database is going to check whether it's satisfied with the condition or not. Okay, so here's just one example. Assuming I have the student table, I have student ID, the name, the GPA, the semester, right? And then I can actually put a check constraint look like this and put a condition here. Essentially, I say, okay, whatever data I put in the database, I want to make sure the following thing is true. That is, the GPA is always between 0 and 4, right? In the American system, I think. Or the semester is smaller than 20 and the semester larger than 0, whatever condition you put here, okay? So as long as they are local to each tuple, it is okay, okay? So let's look at one example. So assuming I insert a tuple like this, SID is 1, SNAME is 1, GPA 1.2, semester is 5, right? So what database is going to do is going to take this tuple and check this condition. Okay, in this case, it's GPA between 0 and 4, yes. It's semester between 0 and 20, yes. So database is okay. You have this, GPA is 5, it's not in the range, database is going to reject. Sorry. So I mean, this is all, right? So like for this tuple, right? So GPA is 5. The first half is going to be false. The second half is going to be true because 5 is between 0 and 20, right? So the whole thing evaluated to true, database is going to be okay. In this case, very similarly, database is going to be okay because now 1.2 is between 0 and 4, right? 20 is actually violate this part, right? So essentially the first part is true, second part is false because I have all connecting these two parts, right? Database is going to be okay, right? So, but what about this case? So this case is a little bit more interesting, right? So I have the GPA as null. Essentially the first half, this part, is going to be evaluated to unknown, right? And then the second part, the semester is 5. Second part is going to be evaluated to true, right? And because I'm connecting them with all, right? The whole thing is going to be evaluated to true. I have unknown or true is going to be true, okay? So it's a kind of 3-value logic instead of just true or false, okay? So in this case, because the whole thing evaluated to true, I'm okay, okay? So it's get a little bit tricky, okay? So we talk about you have unknown or true, but what about other cases, okay? So in this case, the semantic of check is that it's only reject false. Whenever you have the check evaluated to unknown or true, it is going to accept that, okay? So semantic of check is only reject false. So let's look at these two examples, okay? So let's compare them. So I have one example where my check condition is a trivial one, null is not null, okay? And I have another example where my check condition is null equals to null, okay? So if you think about this condition on the left-hand side is always going to evaluate to false, no matter what you put in, right? Because null is always true, null is always false. So essentially, whatever example you put into the database is going to reject it. Okay. And if you look at the thing on the right hand side, right, null equals to null, right, is going to evaluate to unknown. So it will not. So database will not reject this because it doesn't evaluate to false. So in this case, whatever you put in, the database is going to accept that. Okay, so that's the difference. So we can look at one example. Let's see whether this works or not. No, it doesn't work. So essentially, this example, you can hopefully when you go back home, if you click it, I mean, it works. Hopefully, essentially just put these two examples there, and you can see if you define the schema in this way on left hand side, you can whatever you insert into database is going to throw an error, and on the right hand side, whatever you input database is going to be okay. Okay, so it's just a very simple validation that like essentially this is what happens. Okay. So another thing about check constraint is by default, the check happens at tuple level, meaning that every single time you change a tuple, it's going to check this constraint. So let's look at this case, right? So this is not a good constraint, but it's okay for this example, right? So assuming I have student ID, student name, GPA semester. For whatever reason, I have a constraint to say GPA plus semester equals 10, right? Which is not which is a pretty bad thing to do, I guess. But assuming you have that for whatever reason, let's look at the following examples. So I insert a tuple with GPA equals 5, semester equals 5, right? So in this case, database is going to check whether I summing up GPA and semester is equal to 10 or not. In this case, that's the case. Database is going to be okay. And then I update the students table, set GPA equals GPA minus 1, right? So in this case, database not be okay because I kind of like change the GPA like value. Then essentially I'm going to validate the constraint that the sum is 9 or 10 anymore. Database is going to reject it. And if you update two attributes, you make GPA minus 1, you make semester plus 1. If you do this, the database will not check in the middle. Database will check at the tuple level. Okay, so it's going to run both two updates on the same tuple. It's going to decrease GPA by 1, increase semester by 1, and then check the constraint. In this case, it's going to be okay. Okay. So another thing about check constraint is it looks very generic and powerful, but in most of the realistic databases, you can only check, you can only do local check-in of the value of attributes. Okay. And another thing that you need to be really careful is not all the database engines cares about check constraint. Okay, so whenever you are actually using a real-world database systems, sometimes you get counterintuitive result. So whenever something weird happens, like really Google it. There's no way we can cover all those weird cases in this course. And whenever database is doing something weird, it may not be your fault. Okay, so just Google it. So here's one example. I'm pretty sure we cannot open it now, which is unfortunate because it's a really interesting example. Actually, this is the only example I want to show, but actually fine. Yeah. So like in this case, you are going to see there's a bug, for example, in MySQL, right? So that once upon a time, at least so in 5.6, it's actually going to ignore all the check constraints. Right? So it is possible if you are doing MySQL and you are running some of the query that we talk about in this lecture, you are going to get a different result. Not because you are doing something wrong, not because I am wrong, but simply because MySQL, at least for 5.6 version, is going to ignore all the check constraints. Okay, so sometimes the behavioral database is a little bit weird because not all the database actually implement a full SQL standard. Right? Whenever there's something weird about integrity constraint, Google it. Okay, it may not be your fault, it not be my fault. It might simply be an artifact of the system itself. in principle, check could be more powerful, okay? But the system do not support it. So for example, in principle, right, really in principle, I could have a subquery in check, right? So, and that can really make it amazing because you can actually specify a whole bunch of things. But in most of the systems, they do not allow subqueries. Actually, I actually do not know any system support subqueries. Check in our case is always local to each tuple. It can only use the value of a single tuple, not the value of other tuples. Okay. In the exam, we assume there's no subqueries in check. Okay. And I actually do not know any system allow subqueries in check. Yeah. But in principle, there's nothing stop you. If you are building a database system, there's nothing stop you from supporting this. Right? But in real world, at least I don't know any of the real system support this. Also in the exam, we will not like assume you can do subqueries. Yeah, for example, in most of the systems, you cannot do this too. It will be amazing if you can do those, but you cannot. Okay.
Sorry, before you continue, I have two questions.
Go ahead. Yeah.
So one question would be, what do you mean again with conduct local checking of the value of attributes? Like, what's the difference to checking with two tuples?
Oh yeah. So essentially, whenever you write your check condition, you can only use the value of one tuple, right? For example, I have two tuple of the database, like in my relation, I cannot check whether their student ID are the same, right? So if your check condition can only involve a single tuple. For example, you cannot have this sub queries that involve multiple tuples in the check condition. So does that answer the question?
Okay, and now can you go back to maybe a slide, because I don't think I got it.
Yeah.
I don't really got it yet. So here we're just acting on one tuple.
Oh yeah, here, yeah. So here we are actually talking about, okay. So by doing that in the tuple level, we mean two things. First one, it cannot involve multiple tuples because it's a tuple level thing. And second, it's going to treat one tuple as a unit. That is, if you have a query updating two attributes of the same tuple, it will not check in the middle. It will check after you finish updating the whole tuple.
Okay.
For example,
so
you can decrease. Yeah, sir. Go ahead.
So if I understand correctly, this just means we can only do check on one tuples, but as soon as we want to do check with more than one tuple, it's not going to work. Or
that's true. Yeah, that's true. You cannot you cannot have constraints kind of involving multiple tuples.
Okay.
Yeah.
So then I have one more question regarding unique. And is there, so I think there is a difference, but I'm not sure. If we say SID int unique and sname text unique, is that different to saying unique SID sname?
No, right? So they are different. So like we can look at some example, right? So essentially you are actually saying, okay, I have relation, I have SID unique.
Yeah.
And then I have sname unique, right? So this is case one, and then I have unique SID and sname.
Exactly. Yeah.
Right. So these two are not the same. So here's one example. In this example, I'm allowing, for example, 1, 1 and 1, 2. That's fine because the combination is unique, right?
Yeah.
So this is okay. If you do this here, it will not be okay. Why? Because my SID is not unique.
Okay. Yeah. Exactly. That is what I meant. That they're not.
Perfect.
Okay,
Yeah.
Great. Thanks.
So what's the other question? I think I have two, right?
Just one mention. I'm not sure, but you said we should raise our hands, but I don't think you can actually see our raised hands.
Ah, sorry. There's something changed in Zoom. I don't know. I mean, at least in all previous lecture, I can see a pop-up window to say someone raised a hand.
I can't raise my hands. That's also funny. I wanted to, but I can't.
Huh, interesting.
Right now, there's 3 people raising their hands and 4 and 5. Can you
Yeah,
see
yeah,
that?
but I don't see the pop-up window. Yeah, so I can see, I mean, if I open the participants window, I will see it. But that will also overlay with my, okay, anyway, okay, cool, okay. So, okay, now it's fine. Yeah, so now I put the participant window in the corner. I should be able to see. Okay, cool.
I
Great.
also have a question,
Yeah, go ahead.
actually. In the slide where you showed like null is not equal null, right?
Yeah.
You compared null equal null. That does not, but before you said like, can
Yeah.
you even do that? Like
You mean this one?
comparing null to null, because you said before that you cannot.
Oh, yeah. Yeah, so so if you do null equal null, the system going to tell you unknown. I don't
Yes.
know, right? So it's going to evaluate to unknown.
And the check when it checks unknown, or when the check gets unknown, it will accept it.
Yes.
Okay.
So check will accept unknown untrue, unknown
Okay.
or true, right? So I mean, it only reject false. Yeah.
Okay. Thank you.
Yeah. Okay. So any questions? Raise your hand. Now I'm able to see it. I think. Yeah. Cool. Okay. Yeah, so let's take a break. Let's get back in 15 minutes, then we'll continue to talk about constraints. Yeah, I'll be here to answer whatever question you have. Yeah. Okay, so let's continue. So in the first half, we got a very good question that is about primary key and when it gets checked, right? So the question is when you have a transaction, right? So which is essentially you are updating a whole bunch of tuples, you have a whole bunch of statements, you group them together, right? So whether we can have the check of primary key happen after you apply all the updates, right? So the best way to do it is, for example, like you just Google PostgreSQL primary key constraint check after transactions, right? So it will bring you to here, right? So as you can see, whenever you have a constraint, you can actually change its mode, right? So there's one mode called deferred, and there's one mode called immediate, right? So and this is the difference. Whenever you have something deferred, it's going to kind of get checked essentially after all the updates been done, right? So all together. And when it's immediate, right? So it's going to check essentially after like every single update, right? So, and then there's actually 4 different modes, right? And then there's actually some caveat about the compatibility of PostgreSQL implementation and the SQL standard, right? So you can see it's largely consistent, but there's some caveat and here and there. So, and that's a problem of SQL, right? So you have the SQL standard, and then you have the implementation of that. Right? So the best way to do it in practice when you are actually building a real application, right, is whenever you are not sure, Google it, right? So it depends on different version of PostgreSQL, depends on different database system you are using, depends on functionality that you need. The best way to do it is just whenever you're not sure, right, like Google this, right? So in the exam, we will essentially constrain ourselves to the default behavior of PostgreSQL, right? So, but just keep in mind, when if that behavior is not something you want in practice, highly likely there's a way to change it. Okay, cool. So now let's talk about another type of constraints, and that's called referential constraint. So, and also often called foreign keys. So this actually is a type of constraint between 2 relations, right? So if you think about all the constraints that we have been talking about here, they are always on a single relation. Whenever I define the schema, it's there, right? Like local to that relation. Foreign key constraints involve 2 relations. So it's actually the motivating examples here. Assuming I have a lecture relation contains which professor teach which lecture, I have the personnel number of that professor in this relation, and then I have another professor relation, right? I want to make sure every single professor I have in the lecture relation refers to a professor that actually exists, right? So like, for example, I want to make sure the personnel number column in the lecture table cannot take a value that does not correspond to a professor. Okay, so like in this case, right, let's look at this concrete example. It's not about professor, but about student, right? So assuming I have the student table, I have the ID here, and then I have the lecture table, right, to say, this student take this lecture, right? So I have student ID here. I want to make sure all the students, naturally, right? I want to make sure all the students real student who actually exist in the student relation, right? Otherwise, it's going to be weird, right? So here, essentially, constraint I want to say is whatever value you put in this attendance table, they need to appear in this student ID column. Okay, so that's a type of constraint that we want to specify. Okay, so essentially, for every foreign key, one of the following 2 conditions need to hold, right? So the value of the foreign key is either null, so I'm able to put null here, it's fine, or the value, this value need to appear in the referred kind of relation, okay? And then we call this a foreign key constraint. So in this example, right, so assuming that I have foreign key constraint from the student ID in the attendance table to the student ID in the student table, right? So if you do this, if you insert 1, even another tuple into attend whose ID is 1, database will throw an error because it's going to check, okay, you want to insert a tuple where student ID equals 1. I need to check the student table whether the tuple exists. right? So in this case, there's no student with ID 1, so the database is going to reject this, right? So, but of course, it is okay for the foreign key to be null, right? So in this case, if I insert another tuple null here, right, it's going to be okay because it's null, right? That's fine. But whenever you insert something that's not null in the tens table here, the database is going to check whether there's a corresponding student in the student table with that same ID. So to define that, here is the syntax that you can do in SQL. So for example, if I have a relation R here with two attributes A and B, right? And then I have another relation S. So assuming I want to have the foreign key constraint actually from the KA attribute of S to the A attribute of R, right? So I can simply write something that looks like this. Fs, Fka is integer, is reference R, right? So in this case, it's going to use the primary key of R for checking. And you can make that kind of more concrete. For example, you can have T here, another relation, you have KB, reference the B attribute of R. Okay, it means that whatever KB value you put in T, there must exist a value in the relation R, the B attribute. Okay, so it must like exist here. Or maybe KB is null. If that's not null, it must like appear in the B attribute of R. Okay, so in this case, the KA in this case, right? So it's called a foreign key, right? And usually, when you are kind of in like doing this in practice, usually the referred column, right, is often required to be a primary key, or at least to be unique. Okay, so and of course there's a different implementation that may require this or not, but usually if you do not referring to an attribute that is primary key or that's unique, in the best case scenario, it's very slow, right? So like in best practice, whenever you are referring to a tuple, it's better that that attribute that you are referring to is primary key or at least unique. Okay. So and the primary key, right? So as you can see, whenever we are talking about SQL, one thing that we need to accept is often implementation dependent, right? So if you do Microsoft SQL Server, they have different requirement, right? If you are doing MySQL, right, for example, it requires index over the attribute you are referring to, right? In some database, it doesn't have this requirement, right? So the best way to do it is whatever database system you are using, before you write the foreign key constraint, check the documentation to see essentially like the requirement. Okay. So
sorry, could you go back one slide?
Yeah.
So in the second query, is there the A at the end missing, or what does that mean just to referencing a whole relation?
Oh, it will use the primary key by default.
Okay. Okay, thanks.
Cool, great. Yeah. So one thing that's interesting about foreign key constraint is that you can actually try to automatically maintain it in some way. Okay. So let's look at this example. Assuming I have student table, I have lecture table, I have attendance, right? So there are two foreign key constraints, right? So student ID in the attendance table is a foreign key referring to the student ID of student. And then the lecture number attribute of attendance is also a foreign key referring to the lecture ID, right? So what if we delete one student? For example, what if we delete the first student, right? So what can we do, right? So or what if we delete one lecture, like delete databases, right? So what can we do, right? So in this case, whenever you are deleting it, you are going to violating the key constraint. And the fundamental question is, can we automatically also change the attendance table such that the constraint is not violated anymore? So there are actually different type of actions that you can actually define, at least in SQL Standard 2003, to actually define this type of automatic maintenance behavior. Okay, so there are actually 4 different modes. So first mode is called cascade. It's going to propagate, update, or delete. We are going to see one example soon. There's a one mode called restrict. It's actually going to prevent deletion of primary key before trying to do the change. Okay, so and it's going to cause an error if it cannot validate the key constraint. Like we are going to see this like example relatively soon. There's another one called no action. It's actually try to like do all the changes and then check. Okay. Yeah, so like restrict and no action is very tricky. We are going to like spend more time on it. And then there's another action called set default or set null. It's pretty much say whenever whenever I'm violating the foreign key constraint, I set the value to null or to a default value, such that it's not violated anymore. So let's look at examples. It's kind of easier to see that in example. So assuming I have. Hi, hello.
There was a, sorry, I still can't raise my hands.
Yeah, go ahead.
There was a question in chat where apparently you said, or there was a, does tuple null null mean that there is no primary key in a tens? If yes, is that a problem? I think at one point you tried to enter a tuple null null and that violated a constraint.
Sorry, I don't really understand. Can you?
It was about 5 minutes ago. I don't remember what slide that was on.
Yeah, probably here, right? So is
Yes.
it about this example?
Yes.
So for example, like
10.
the student ID here is like in the tens is foreign key, right? So this value, if you put null here, it's going to be okay anyway. Okay.
But how can that value even be in a table? In a table, because the table needs a key, right? And the key cannot, it has a not null requirement, right? Or am I wrong?
Ah, that's a very good question. Okay, I see. Okay, I see what you mean. Okay, so essentially your concern is that a tens table, assuming I have a primary key, and that's a combination between leggy and the number. If I put a null here, that's going to violate the primary key, right? Is that your concern?
I think that's the it's not my question, but I mean, I'm asking myself that is my question.
Yeah,
it is the question. Someone just answered.
Yeah.
Sorry.
Okay, so yes, in that case, it's going to violate the primary key constraint, but it will not violate the foreign key constraint.
Okay,
right?
So in practice, that would not work. But in theory, if we just care about,
I mean, if you do not specify leggy and the number as a primary key, then it's okay. You can put null there.
Okay. I think I get it. Thank you.
Yeah. So putting null will not violate the foreign key constraint. It might violate other constraints, right? But the point here is that it will not violate the foreign key constraint.
But just a one follow-up question, maybe, just to make it clear. In SQL or SQL, we don't necessarily need a primary key or unique, right? We can just have a relation without a primary key and without you specifying anything as unique.
Yes. So in SQL, in database, you do not need to put primary key on relation. I mean, you could have relation without a primary key.
Okay.
In relational model, that's not the case. In relational model, you always need the key. Yeah. Okay.
Right. Okay.
Yeah.
Thanks.
Cool. Okay. So let's look at these 4 different behaviors. Okay. So the first one is cascade. So assuming I have the foreign key like in a tens, right? That's an ID there. And then assuming I delete one student. So if you have the foreign key in the cascade mode, right? So what's going to happen is if I delete this, the database is going to delete the corresponding tuple in the tens table. Okay. So in this case, these students corresponding to these 2 tens tuple. Okay. If you delete this one, the database is going to cascade the change. Okay, so it's going to delete these 2 tuples. Okay, and if you are doing this in the restrict mode, so if you delete like this tuple, so database is going to like essentially like try to check whether this is get violated. So in this case, right? So if you delete this tuple, I will going to have these 2 tuples referring to a student that doesn't really exist, and then it's going to throw an error. So similarly, no action, it's the same. Okay, so you try to delete this, database is going to check whether it's going to violate or not. In this case, it's going to throw an error. So there's a very manual difference between restrict and no action. We are going to see that in the next slides. Okay, so just keep that question in your mind. And then if you do set null, what's going to happen is if I remove the student, database is going to set this value to null, this value to null, such that the foreign key constraint is still okay. Okay, so this is the 4 different behaviors that database can do automatic maintenance when you have a foreign key constraint. Okay, so how to define it? So whenever you are kind of specifying the foreign key constraint, you can have this kind of additional thing here. You can say on delete, you pick one of this mode. On update, you pick one of this mode. Okay. So and then essentially that's going to specify whenever essentially how to automatically maintain this specific foreign key constraint. Okay, makes sense? Okay. So there's a very tricky thing about restrict and no action that we are going to spend some time on it. So the very, very subtle, and in many databases, they actually, you will not see difference at all, okay? So
can I interrupt you?
Yeah.
Sorry.
Go ahead, go ahead.
If you go back a slide, right?
Yeah.
So if I understood restrict correctly, it does not allow the deletion of primary keys. But what if we have a foreign key which is not a primary key, for example, unique or not even unique? Is that allowed, or is that also not allowed?
Sorry, can I say that again? Sorry.
Right. So if you have a foreign key, and so we have one relation which uses like refers to a foreign key in another relation, and that is not a primary key. But rather it's just like unique, or it's not even unique.
So I have RNS.
Right.
Can you give a concrete example?
Maybe let's go with Leggy number. And then we would have an S, maybe Leggy number and lecture ID. Right? So if Leggy number is a primary key, then we cannot delete it.
So it's a primary key in what? In
R, right?
Okay.
So in this case, we would not be able to delete anything from Leggy when we go restrict. Is that correct?
And your foreign key is from where to where? From R to S, or from S to R? Sorry. Yeah.
From S to R. So the
Okay,
Leggy in S refers to the Leggy in R. So that's yeah.
Okay, cool. Yeah. So now settings clear. Okay. So and you want to delete. Okay. And what do you want to do? Yeah.
Okay. So right. So we want to delete something from R. That's not allowed with restrict, right?
That's not allowed. That's true. That's not allowed in R.
Right.
Yeah, so that's not allowed in restrict. Like assuming they are tuples in S, referring to that tuple you want to delete in R. That's true.
Okay, so first of all, it only refers to, so it only holds for tuples which actually refer to things in R. So if something does not refer to,
Right. For example, in R, you could have 1 and 2, like in this case. And in the student, you have, for example, 1, like whatever. You have 3, whatever, right? So in this case, if you delete this guy, it's not okay if you are doing restrict, right?
Right.
If you delete this guy, it's fine.
Okay, so let's say Leggy is not a primary key, but just unique.
This one is just unique in R, right?
Right.
Okay.
So does restrict do anything anymore? Because on the slides it says it only talks about primary keys.
If this is unique, if you delete 1, if you do restrict, it still has problems, right?
Okay.
Okay, I see what you mean. So okay, okay, I see what you mean. So okay, now I understand. Let me try to rephrase your question. And essentially, like your question is still here, right?
Maybe.
Yeah,
Actually,
so,
I don't.
right. So like this is the only place we talk about primary key, right?
Right.
Yeah. So like essentially, whenever you have this, essentially
Yeah.
you are actually referring to the column A. And your question would be, what if A is unique and you have this? Is that your question?
No. So it's actually, if you go a slide, it's not that important actually. So maybe, but if you go a slide forward where we talk about the different modes of how to deal with the violation of constraints.
Yeah.
The only point that I was thinking about it, so restrict says prevent deletion of the primary key before trying to do the change.
Okay, I see.
So I'm saying,
okay.
what if it's not a primary key, what just unique or just anything?
Okay, I see. That's a good question. Actually, I don't know. So I need to get back to you. Yeah.
Okay.
So I think I just copied from the SQL standard, but yeah, so that I need to check. Yeah, sorry. Yeah. So yeah. So yeah, let me keep notes on that. Yeah. So that I need to check.
All right. Thanks.
Yeah, but I'm pretty sure in PostgreSQL it doesn't need to be a primary key. Yeah. I'm almost sure. Yeah, but I need to check and get back to you. Okay. So can you send me an email to remind me? Otherwise, I might forget about that. Yeah.
I mean, I'll probably forget myself, but I'll try.
Okay. Yeah. Okay. So I'm also cool. Great. Yeah. So I mean, in the worst case, I will update the slides. Yeah. So if I forget to get back to you, yeah. Okay. Cool. Okay. So there's a very minor difference between restrict and no action, and in many database systems, you will actually not see the difference. But in some databases, you are able to see it. So the difference is when you do restrict, it's going to throw error immediately, and when you do no action, it will actually try to apply all the updates and then throw the error at the end. Okay. So let's look at these two cases, and this is actually different database engine is SQLite. Okay, so you have B and A, two relations, and you have the foreign key, the A column of A, referring to the B column of B, and then in one case you have restrict, another you have no action. Okay, so and I insert essentially two values, both A and B has 1. That's going to be fine, and then you can think about this as a group of a statement that you want to run together. Is called a transaction, right? And what's going to happen when you have restrict, it's going to check in the middle. Whenever you finish one statement, it's going to check it. So it's going to throw an error in the middle. And if you have no action, it's going to check after this group of statements. Okay, so it's going to do that at the end. So in this case, you increase the B by 1, you also increase A by 1, it's going to be fine. So it's going to run okay in this case. However, if you are doing restrict, here you are doing the increment of B first, and then you kind of violate the foreign key constraint, the database is going to throw an error for you. Okay, so that's the difference. I actually don't know whether in PostgreSQL can see such a difference or not, but at least in SQLite in this version, it actually have that difference. There are many database systems actually you will not see it, but in principle, you should understand the difference. Okay, so restrict will throw error immediately whenever the constraints get violated. No action is going to defer in that and check that all together when all the updates are finished. Okay, so that's the fundamental difference. Okay, so now let's look at some examples. So this is our university database that we have been dealing with for a while, right? So whenever you are defining the schema, right? So here are some constraints that might make sense for this database, right? For example, when you are defining student table, right? So it's very important for semester between, for example, 1 to 13, right? So in this case, you can have the check constraint to specify that. And when you have the professor table, for example, maybe there's 3 different level of professors. You want to make sure you cannot put an arbitrary value there. You can actually have a check condition to say the level is always one of these three, right? So you want to make sure, for example, the room of a professor need to be unique. You don't want two professors in the same room, for example, for whatever reason. And then you can have the room as unique constraint, right? You have the primary key, right? Of a professor. You want to make sure every single professor has a name in your database. You can have the not null constraint for name, right? And this all makes sense, right? As you can see, whenever you are building a real world database systems, you can actually use what you have been learning so far to actually specify what you are allowing in your application, such that your downstream queries or downstream applications will not be surprised, right? So yeah, go ahead. We have one question.
No, that was not a question, but
I don't think it's a question.
Yeah, but I mean, I'll just take this opportunity anyway. Still not restrict. So what if, so the way I understood it, we do the action and then we check, but the way I understood restrict was the following way. Let's assume we have our relation from before.
Yeah.
So we have like the Legi numbers 1 to 10 in one relation, and then we have another relation which links lectures and Legi, similar to this one, right?
Yeah.
And exactly. So, and then in S, we only have, for example, 1 and 3.
Yeah.
So if we delete the Legi number 10 from R, is that allowed with restrict?
Yes, that's allowed.
All right, so the difference.
Okay, so you are making me nervous. I would say it is allowed, but I need to check. Yeah, so I will be really surprised if that's not allowed.
Because the formulation is a bit weird, because I think it says it throws an error before checking, or I'm not sure what it says exactly on the slide.
Oh yeah. So I think okay. So let me do my homework, update the slides, and I will send a message on Moodle to clarify that. Yeah. Yeah.
All right.
So I get your question. I get why you are confused. I think that's my problem. I will. I will double check and I will send a message to Moodle. Yeah.
Thank you very much.
Yeah. But I will be really surprised if that's not allowed. Yeah. But I need to check. Yeah. Okay. Yeah. And I will update the slides. Yeah. Yeah, so now I see why it's like confusing. Yeah. Cool, great. Yeah, so and you can like for example, yeah. So for example, whenever you are defining the lecture table, right? So like one thing that could make sense is the lecture number is primary key, right? And you have the professor teaching this lecture, right? So maybe I want the professor number to be a foreign key, right? To make sure it's always referring to a professor that actually exists, right? And for example, whenever you're deleting a professor, maybe I want to set the professor number to null, right? So, and then if you want to do that, that's a constraint you want, you can actually do something like this, right? You can have personnel number, integer, references, professor, right? On delete set null. And then we have like a tensor relation, right? You can do something essentially very similar, right? So when you go back home, you can read this. It should all make sense to you. Okay, so now let's think about one interesting case. That is when we are talking about the entity relationship diagram, right? We talk about the cardinality, right? So can we use the thing we have been learning so far to enforce a one-to-one relationship, right? So how can we encode this? Assuming that we have two entity sites, we have employee, we have office. We want to specify that one employee can have at most one office, and on the other hand, one office can be assigned to at most one employee, right? And there's this one-to-one relationship between employee and office. So what can we do? So let's look at this example, right? So assuming that I'm defining two relations, one is office and another is employee. And for office, I have the room number, which is the primary key, and I have the here professor number, right? So which refers to employee, right? So and then this one is a foreign key. And then on the employee table, right? So I have a professor ID as a primary key, and I have the room refers to office. Okay. So does this encode a one-to-one relationship? Right. So in this case, it's actually very interesting. It actually does not. So let's look at one example. So assuming I have two offices, I have O1 and I have O2, and assuming I have two employees, E1 and E2. Okay. So the following case is possible in your schema. That is, I could have the employee ID of Office 1 linking to E1. Okay. And then I could have the room in the employee 1's record point to O2, right? So that's allowed like in the schema, right? On the other hand, I could have O2 point to E2 or can have like E2 point to O1. So as you can see, this doesn't really define kind of one-to-one relationship between office and the employee. Okay, because whenever you are specifying this type of foreign key constraint, you actually do not have anything saying whether the professor ID in office need to point to a professor whose room is consistent with the room ID of office, right? You could have this type of like relationship, O1 point to E1, E1 point to O2, right? So this doesn't really give you this type of one-to-one relationship. So, but what if we really want to encode a one-to-one relationship, right? So here is just one way to do it, right? So let's think about this. You have an employee table with employee ID, and you have an office table with a room ID. And then I create another relation called has office with the first attribute, employee ID, and the second attribute, room ID. It's essentially specify which employee has which room as office. And then I set employee ID to be not null, unique, and refers to the employee ID attribute of employee. And I have the room as not null, unique, refers to the room attribute of office. So if you do this, right? So in the has office relation, I cannot have one employee associated with two different rooms because that's going to violate the unique constraint here. And I cannot have one room assigned to multiple employees because that's going to violate the unique constraint here. And I cannot have one employee mapped to a room that is null. Otherwise, it's going to violate the not null constraint of room. Similarly, I cannot have a room associated with an employee that is null because otherwise it's going to violate this. On the other hand, employee ID need to link to a real employee because of the foreign key constraint. On the other hand, the room need to reference to a real room because of foreign key constraint, right? So as you can see, this is just kind of one way to enforce this type of one-to-one relationship between employee and office, okay? And of course, there could be other ways to enforce it, right? This is just one way to do that. Whenever you are defining foreign key constraints to enforce different kinetic relationships, just be careful, right? So maybe the first design come to your mind have some limitations or might not fully enforce what you really want to enforce. Okay, so we are a little bit fast today, actually a little bit slow, depending on how you see it. I think that's all the content for today. In the next lecture, we can talk about recursion, but it doesn't really make sense to start right now because we only have 10 minutes left. That's all for today. So in the next lecture, we are going to talk about essentially how to write more powerful SQL queries to really implement recursive queries inside SQL, right? So, and yeah, so that's all for today. I'll be here to answer your questions. And I will send another message to Moodle to really clarify the two different modes, that is restrict and no action. That's on me. Yeah, so otherwise that's all for today. Yeah, thank you.
Have a nice day.
You too.
I have a question concerning the one-to-one relationships.
Yeah.
When we speak of a one-to-one relationship, do we still think of an optional relationship? So if an entity is in a relationship, it must be a one-to-one, but one entity does not necessarily have to be in a relationship? Because with this construct we have right here, it would be possible to insert tuples into employee, which have no corresponding has office tuple, right?
That's true. So a one-to-one relationship can be optional. The reason, the fundamental reason is if you go back to the formal semantic that we talk about, I think lecture 7. Let me try to bring that here. Just give me a minute. Okay, it's here. Okay, so yeah, so because if you go back to the formal semantic, right? So whenever there's a one, right? I'm essentially the left-hand side of the imply essentially means that the whole thing is optional, right? So if you do not participate in a relationship, that's fine because this one is going to be false, the whole thing going to be true, right? So it is okay for entity does not participate in any of the relationship if you have those like one-to-one constraints, right? But if you participate in something, it need to be one-to-one. Right, so that is the semantic.
Okay, and I guess then there is no way to express such a thing as a mandatory relationship.
Good question. So I'm trying to. Okay, so yeah, so let's think. So I'm trying to think whether we can do that in foreign key. I mean, you can definitely do that for using trigger, but for foreign key, that's something to check whether you can have those, like, for example, so like, for example, like you can have foreign key from employee ID to this, right? And then make sure essentially you're saying that whatever I put in employee relation, it need to has office. And then you have this foreign key. Essentially you have two foreign key, one referring this to this, another this to this. I'm not sure that's allowed.
Okay.
But I need to check.
Okay, but
if that is allowed, then that give you this non-optional semantic, right? But I'm not sure that's allowed. Yeah.
I'm sure there's like a practical way with triggers or something like that to enforce it in the DBMS. But my question was actually more like, is there a way to express such a thing as a mandatory relationship in the ER diagram?
Yes, there is something called optional. There is something called a mandatory, right? So yeah, you do have the like the tool to deal with that, right? So I mean, simply it's like we didn't talk about that in the lecture. Yeah.
Okay.
Yeah.
Thank you.
Cool.
I have a question about today's lecture.
Sure.
Would you please go back to the slide where we do the check constraints?
Yeah, sure. Check here.
Yeah.
Yeah.
One slide before this, please, if I'm not mistaken. There where we have null equal to null, slide 12.
Oh, it's here, right? So yeah,
that's
okay.
right.
Yeah.
On the right side, we see, yeah, it's correct. null equal to null, then we got the unknown time. But as I read in the book, the unknown time doesn't always return true back. Like if you have on the left side null or on the right side null, sometimes it binds arbitrary value in it, and then it could return true, but sometimes it returns something different, and it could be a false. Or am I mistaken?
I'm not sure I understand. Sorry. So you mean this null equals null could return true in some database systems?
So if I run the query like this, create table students, so I add one constraint in this table, like for example, check GPA equal to null, and it always has to be true to be able to insert it in this table. Like now I'm doing a query and then I let my GPA.
Yeah. Sorry, let's write it down, right? So to make sure we're on the same page, right? So since we got one query to say, okay, I have check GPA equals to null.
Mm-hmm.
Okay, so like this is the first case. So like in this case, this one will always be unknown.
Mm-hmm.
So this one should always accept.
Yes.
Right.
Why is it always accepted when it is unknown? Because unknown is a time where we don't know anything about it. It could be true, it could be false.
Oh yeah. So the semantic of check is it only reject false.
Accept unknown as well. Okay, I didn't see it. I'm sorry.
Yeah. So it's only accept false. So when this condition evaluate to unknown, it's going to accept it. It is simply how check is defined. Yeah.
Yeah, now I get it.
Yeah, because you have 3 values, you need to pick one case, right? So like happens, I mean, this happened to be the thing the SQL standard defined. Yeah.
Yeah. Now I get it. Thank you very much. Have a nice day. Bye.
Okay, so if there's no other questions, I'll see you guys in the next lecture.